Okay, we're just going to look at, I think it was question 4, was it? Question 5. All right, so let's look at question 5, which was our function. So here's the function. All right. We need to sketch this non-calculator, indicating clearly any asymptotes. So we're going to need to know if there's a horizontal or vertical asymptote. And we need to know points of intersection with the x and y axis. So x intersect and y intersect. So we need these 4 bits of information. All right, so let's start off. I think we can find the vertical asymptote quite easily. I think you guys did. The vertical asymptote to this we need to find that equal to 0, don't we? So what value for x will make that 0? And I think it's -3. And it's actually given in the question that x can't be -3. So that's the vertical asymptote, and that's okay. Now the horizontal asymptote, Nigel, I forgot what answer you did, but we discussed it briefly on the meet. That the horizontal asymptote in this case is not going to be 4.
Yeah, it's going to be 5. You got to add that, right?
And you could prove that it's not 4 by letting 4 equal, and then take away that. That's going to be 3 on this side. This is unnecessary work. I'm just proving it anyway. So when I multiply both sides by x plus 3, I get 3x plus 9 is equal to 4x. That's fine. That's fine. What I want that to be is 4, because then I have 4x plus 9 is also equal to 4x. That wouldn't make any sense. And that's the reason why it can't be 4. It must be 5. And of course, if we have a translation here of up 1, so that's why also it is 5. So either way, it is 5. In other words, because if this was 5 over this side, that 5 minus 1 would give 4, and that would give 4x. Okay, and that's the reason why the horizontal asymptote would have to be 5. The x-intercept and y-intercept, I think we got that in the exam, both you guys, and I don't think that's a major issue. Letting x equal to 0 and y equal to 0. I think when you let x equal to 0, that all equals 1. So that'll be the intercept, 0, 1. And when we let y equal to 0, so you have to do a little bit of solving, we let y equal to 0, I think you get -3/5 and 0. I think you both got that, so we won't go into that. Okay, so that is all of part A done, bar the sketch itself. So you would have to draw an x and y axis. I'm just looking at what points I have here. I know I need to go up to 5, and I know I need to go back to -3. So definitely, I think, okay, it's actually going to go up. Yep.
X-intercept, you just let y equals 0, right?
Yes.
Yeah. Wait, I got -1/4, but I mean, when you do x plus 3 times 0, it'll be 0, right? So you just get 1 plus 4x. That's all you're left with, right?
Let's do it. So when I left y equals 0, so fx is y, so that 0 equals 1 plus 4x over x plus 3, yeah?
Yeah, and then you multiply x plus 3 to 0, so it's just going to be 0 equals 1 plus 4x.
What about the 1?
Oh, okay, sorry. That's right.
Take it yesterday. -1 is 4x plus 3.
Okay, yeah. Now I understand, yeah.
Now it would be -x plus 3 is equal to 4x. -x minus 3. And then that's how you get the -3/5. Okay?
Sir?
Hi.
Can you send the recording of last lesson and also this lesson today?
The recording for the last lesson is up already on YouTube. I'll send it, yeah.
Okay, thank you, sir.
Okay, so that was the our point. So let's just put in that point. Y equals 5 is a horizontal asymptote. 1, 2, 3, 4, 5. You should include, of course, the markings on this if it's an actual exam question. Just label it properly. So y equals 5. Vertical asymptote. X is equal to -3. So that's back here somewhere. X is -3. I already realized I've made an error with my scaling here. Not my scaling, but how much room I've left for the actual graph part of it. Let's put in our, so 0, 1 is the y-intercept, 0, 1, so there, and -3/5, 0 is really close here. So something like that. So they're close. And we know the shape of a rational function. It should go something like that. And it's going to tend towards those two asymptotes there and there. And it would have a buddy up here. Unless you could test a point up there if you really wanted to. We know it's beyond -3. So if you want to test -5, you'd find it somewhere there. And you can test that if you want. But you should know that shape anyway, the double form of that shape. Okay, so that's our sketch. All right. So that's part A done. Let's look now at part B of this question. Find the expression for f inverse. So here's our original function, x plus 3. And now I've got to find x as the subject pretty much, and then swap the letters. So
Wait, part B is asking for the inverse, right?
yeah, -1. All right, so now I multiply both sides by x plus 3, but before I would do that, I would probably -1 from both sides. So it's a bit of a cleaner kind of multiply, because otherwise I have to multiply this 1 by x plus 3 as well. I can multiply it over here. It's the same difference, but it's just tidying up a little bit before I do that. So multiply both sides by x plus 3. So that's x plus 3 times y minus 1. And that equals now 4x, because the x plus 3s will cancel on that side. That's xy. I'm just multiplying by x. Minus x, and multiply by 3. Plus 3y minus 3. And that equals 4x. All right, so hopefully there's no issues there. Remember, I want to get x as the subject now. So that means group all the x's on one side, group the y's on the other side. So I get xy minus x minus 4x from over here. Subtract 3y, add 3 to that side. That's minus 5x, isn't it? So take x out of that, and I get y. That was minus 5x, so it's just minus 5 now. Minus 3y plus 3. Divide both sides by y minus 5. So x equals y, this minus 3y plus 3, divided then by our y minus 5. Okay, and that is it. Not fully done, but we would have to rewrite it with x's and y's swapped, of course, because it's the inverse. You would write f minus 1 of x equals minus 3x plus 3, or you can write these the other way around if you want, and y minus, or it's x minus 5, so just swap those letters. You could have swapped the letters at the start, so hopefully that made sense. Both Dustin, you, and Badai, both of you made the mistake, an algebraic mistake here at the start. You didn't multiply that 1 by x plus 3. Both of you made
Yeah, I figured that one out too.
We looked at that yesterday briefly. Okay, so that was it.
Wait, sir.
Yeah.
Negative 3x from where again? What step do you get negative 3x from?
Here,
Yeah.
so it was negative 3y.
Yeah.
So that negative 3y, it was a positive 3y here. It means it's a negative 3y on that side of the equals.
Okay. Yeah. That's my bad.
Okay, yeah. All right. Okay, so part C then.
Is this the absolute value or?
Part C is where they find the values where it says find the values where one function equals the other function. In other words, where they would cross over.
Oh.
So I know one function from the question, and I know the other function because I just found it. That's from the question, and that equals, and then I know the other function from the question, and I just found it. That's from the question, and that equals, and then I know the other function from the question, and I just found it. That's from the question, and that equals, and then I know the other function from the question, and I just found it. That's from the question, and that equals, and then I know the other function from the question, and I just found it. That's from the question, and that equals, and then I know the other function from the question, and I just found it. That's from the question, and that equals, and then I know the other function from the question, and I just found it. That's from the question, and that equals, and then I know the other function from the question, and I just found it. That's from the question, and that equals, and then I know the other function from the question, and I just found it. That's from the question, and that equals, and then I know the other function from the question, and I just found it. That's from the question, and that equals, and then I know the other function from the question, and I just found it. That's from the question, and that equals, and then I know the other function from the question, and I just found it. That's from the question, and that equals, and then I know the other function from the question, and I the other one, which I just found somewhere. Where did I write it again? Minus 3x plus 3. So I had it on the back of that page. What was it again? X minus 5. So I want to find answers for this. As soon as I know that that equals that, I can find values for x for this. All right. So I will solve. It's an algebra question. Common denominator would be, the common denominator here, CD, for common denominator, would be x plus 3 times x minus 5. So everything must be multiplied by x plus 3 times x minus 5 to get rid of these two denominators. 1 included. So 1 is the first thing to be multiplied by both of them. The second term, so that's times 1. So that's that one. The second term only needs to be multiplied by x minus 5 because the x plus 3's will cancel. So 4x times x minus 5 equals. This one doesn't need to be multiplied by x minus 5 because that would cancel, but it does need to be multiplied by x plus 3. Okay, so hopefully you'll be able to solve this fully out. I'll very quickly go through it, and I can slow down if you need me to. But this is an algebra question, not really a functions question. The only bit at the start was the functions bit. All right, so we got x squared minus 2x minus 15 plus 4x squared minus 20x is equal to minus 3x squared minus 9x plus 3x plus 9, I think. I'm going to collect all like terms over on the left-hand side and let it equal 0. X squared plus 4x squared is 5x squared, and another 3 is 8x squared. 2 minus 2x, that's minus 22. Minus 22, and I think that's minus 6. Minus 22. Minus 6. Oh, that's be plus then when it comes over, so it's actually minus 16x. Oh, what have we got here? Minus 15, minus another 9. So that's going to be minus, what's that? Spider just landed on me. 24. Okay, so hopefully that's okay. Solving that, well, I can divide by 8. All terms can be to make it an easier solve, I think. That'd be an easier solve. You could have solved it at this stage, same difference. X, 3, 1, minus, plus. Yep. So x is either minus 1 or x is equal to 3 when we solve that. And there's the two values for which, that's it. To find all values for x. You don't need to find the corresponding y values.
Wait, sir. I messed up my inverse function. I got positive 3x at the top.
Yeah.
I was still able to somehow get the correct answer on the other side.
You're able to get this correct answer?
Yeah, but I did the points, so I did a step extra.
Yeah, well, that's, you don't get any extra marks, but perhaps coincidentally, I can have
Yeah, I messed up twice and got lucky.
Yeah, I think that's probably it. I can have a check in a while and just make sure what marks. I know that for question 5, you got 12 out of 17 marks. So I can't say for sure where those marks are at the moment. I have it written somewhere. Okay, so that was part C, which was find the values. Now it's the absolute value bits. So the first bit is where the absolute value of the function is greater than or is less than 2. All right. Right, so the absolute value is less than 2. So if the absolute value is less than 2, that means, well, if I wanted to remove the absolute value, what could I say? I can say that. Hopefully I can say that. So the function is going to be still less than 2. But what would I put on this side?
Negative infinity.
No,
Oh, the absolute value, right? -2.
-2. Yeah. So that's a pretty standard jump for absolute value. So it'd be between, because it also where all the negatives, as long as it doesn't go over. So -3 then would be outside the range, because absolute value of -3 would be 3, of course, which is more than 2. So between these two, so then it's just a solving. You can do inverse for this if you want, but they use the inverse function, but I think it's easier just to solve then two equations where f of x is less than 2 and where f of x is greater than -2. Solve those two, and then you can find your range of values from that. So do that 2 times f of x less than 2, and then f of x greater than -2. So in between those two is our set. We find a set of values. So solving that, I know the f of x function is still 1 plus f of 4x plus 3. That's greater than -2 here, and 1 plus x plus 3 is less than 2. So do it twice. This one, I get 4x plus 3 less than -3. And then I can multiply both sides by x plus 3. That'll be -3x minus 9. And then 4x, and then plus the 3x, so that's going to be 7x, is greater than -9. So that means when x is greater than -9 over 7, the function will be between those two values. And solving this one, 4x, x plus 3 less than 1 now, subtracting 1 from both sides. Multiply both sides by x plus 3 again. Subtract that over, and x is less than 1. So we have a range of values for which we've solved the inequality. So when x is greater than -9 over 7 and less than 1, the absolute value of the function will be less than 2. Okay. All right. So that's the absolute value question. The first part. The second part, part E, or last part. What happens if the absolute value is inside? If x is the absolute value. So the other one was when y was the absolute value, pretty much. This time, it's the input is absolute valued, so any input will now be positive. Okay, so how do I do that? Once again, it's an algebraic equation. Our function is 1 plus 4x all over x plus 3, and that's going to be less than 2 when x is an absolute value, when x is positive. What range of values can I work with for that? Okay, so I'm just going to treat this as a normal x and just see what happens. So 4 times the absolute value of x will be less than 2 times the absolute value of x plus 6. I think. Am I right in that? I think I did this wrong in my notes, but anyway, I need to do it again. So 4x, then take away the absolute value of 2x, we give 2 absolute value x, and then 6 take away 1 would be 5, and then divide both sides by 2. The absolute value, once the absolute value of x would be less than, well, 2.5, I suppose, or 5 over 2. Let me just check the answer, not the mark scheme answer. Well, first I'll check, does that make sense? If the absolute value of x is greater than 2.5, the function will be less than 2. So that means for x between -2.5 Does that make sense, that the function will be below 2? I suppose, do we have the sketch of the function? We have somewhere a sketch of the function. Sorry, I'm just checking my answer because I made a mistake when I did out my mark scheme. When I did out my answers. 2.5. Yeah, so 2.5 here. No, you're not seeing 2.5 here. This is not the graph of the absolute value of x put in, but I'm just looking at how it would be reflected. Yeah, so this one would be reflected minus 2.5. I think it makes sense. Second, so I just double check that. No, I have made a mistake. Where's my mistake? Oh, I knew there was something wrong. I wrote this wrong. That would be the right answer for that one. 4x over x plus 3 like that. The plus 1 is not divided, so I knew there was a mistake. So scrap that for a second. Let's do that again. So that 1 is not divided. So let's bring that over to the other side. 4 to the x all over x plus 3 less than 1 now. And then I get 4 to the x less than, now multiplying that by x plus 3, I get, and then subtracting the absolute value of x from both sides, I get 3 absolute value of x less than 3. And then the absolute value of x is less than 1 dividing both sides by 3. Scrap this answer. It's between minus 1 and 1. Okay, that makes more sense. All right, so that's the answer for the last part. So that's where the absolute value, and you can check that if you want to put it on Desmos. You can put in that into Desmos if you want, and then you can see that that function is below 2, between minus 1 and 1. And you can check the other one on Desmos if you want. Just draw it with the absolute value brackets, and you will get, so put the absolute value brackets around the function and see what that looks like. And then you can see what values for it lie below, was it 2? So you can have a look. Have a look at those if you don't believe me. All right. So what I do need from you guys today is